You know that feeling? That moment of déjà vu that's so intense it feels like a hiccup in the world? Or when you look up at the night sky and just wonder, is all of this, is it even real? Well, today we are diving headfirst into one of the most mind-melting ideas out there, the simulation hypothesis. And this isn't some fringe idea anymore. It's gone totally mainstream. You've got tech giants like Elon Musk saying the odds that we're in the one true base reality are like 1,000,000,000 to 1. So yeah, this has definitely moved out of the dorm room and into the labs of physicists and philosophers. So what's the deal here? Is this whole thing just a fun bit of science fiction? You know, a cool concept for a movie like The Matrix? Or is it something more? Does it actually point to a deep, fundamental truth about our existence? Let's get into it and see what this whole argument is really about. Okay, so the whole computer simulation thing, that feels super modern, right? But the core question, is the world I see around me the real world? Man, that is an old question. It turns out we humans have been questioning the fabric of reality for a very, very long time.
I mean, we're talking way back in the 4th century BC. You had the Chinese philosopher Zhuangzi, who dreamed he was a butterfly. When he woke up, he couldn't figure out if he was a man who just dreamed of being a butterfly, or a butterfly who was now dreaming he was a man. Wild, right? Around the same time, you had Plato over in Greece with his famous allegory of the cave, suggesting we're all just prisoners watching shadows on a wall, thinking it's reality. Fast forward to 1641, and René Descartes is worrying that some evil demon is feeding him a total illusion. And then, of course, 1999, The Matrix comes along and just blows the whole idea up for the digital age.
But things really, and I mean really, kicked into high gear in 2003. That's when a philosopher named Nick Bostrom published this incredible paper. He took this ancient philosophical question and turned it into a cold, hard statistical argument. He stopped asking what if and started asking what's probable. Now, Bostrom didn't just come out and say, hey, we're in a simulation. Nah, he was much more clever about it. He gave us what's called a trilemma, basically a choice between 3 options. And his argument is that if you make a few pretty reasonable assumptions about where technology is headed, one of these 3 things is almost certainly true. Okay, so here are the 3 doors he says we have to pick from. Door number 1, we go extinct. Game over. We never get to that posthuman stage where we have insane amounts of computing power. Door number 2, we do get to that stage, but for whatever reason, maybe we find it unethical, maybe it's just boring, we decide not to run a bunch of simulations of our ancestors. Or door number 3, if 1 and 2 are false, if we survive, and we decide to run these simulations, then we're going to run tons of them. A truly mind-boggling number of them. So many that simulated people would outnumber real people by an astronomical margin. And that is the absolute core of the argument. If there are billions, maybe trillions of simulated people in existence, but only one original base reality, where do you think you are? Right now. Just based on the odds, you are almost certainly one of the simulations. We're talking like a 99.999% chance. It's just a numbers game.
Okay, so the statistical argument is pretty powerful. It's a real brain twister. But that's just logic. What about actual physical evidence? You know, if our reality is just one big program, shouldn't we be able to find some of the code? Or maybe see the pixels if we look close enough?
This quote from physicist Max Tegmark really gets to the heart of it for a lot of scientists. Because the deeper we look into the universe, the more we find that the fundamental rules are just pure mathematics. It's almost too neat, too clean. It feels less like messy nature and more like the elegant, rigid rules of a computer program. And people are finding potential clues everywhere. First up, you've got the observer effect in quantum mechanics. The fact that particles seem to exist in a fuzzy cloud of possibilities until they actually look at them. To a programmer, that sounds a lot like a shortcut. Why render the whole world in high def if the player isn't looking at it? Then you have this idea that space-time itself might be made of tiny pixels, a cosmic resolution limit that we might be able to detect. But the weirdest one? Physicist James Gates was working on string theory equations and found error-correcting code. Literally the same kind of code your web browser uses to work properly, just sitting there, hidden in the math that describes our universe. I mean, even he said that after finding that, he couldn't call the simulation proponents crazy anymore. But of course, let's pump the brakes a little. Not everyone is on board with this idea. For every physicist searching for glitches in the matrix, there's another one who argues that simulating a universe like ours isn't just hard, it might be logically impossible.
And the big debate here isn't just about whether we could ever build a computer powerful enough. The real argument is deeper. It's a question of logic. Some scientists believe our universe has certain qualities that simply can't be computed by an algorithm, no matter how much power you throw at it.
And one of the biggest weapons in the skeptic's arsenal is something called Gödel's Incompleteness theorem. To put it simply, it proves that any system that runs on a fixed set of rules, which is exactly what a computer program is, will always have true statements that it can't prove. Think of it like a calculator. It can tell you 2 + 2 = 4, but it can never prove the concept of addition itself. And the argument goes that if our reality contains these kinds of non-algorithmic truths, then it just can't be a simulation. A simulation is, by definition, an algorithm from top to bottom. And there are plenty of other good reasons to be skeptical. For one, our universe is incredibly complex and, frankly, inefficient in weird ways that just don't make sense for a simulation. Then there's the whole infinite regress problem. If we're a simulation, who simulated our simulators and who simulated them? You get stuck in this endless chain. Also, you have to ask, why? Why would some super advanced civilization bother simulating us? And maybe the most straightforward argument of all, the fact that we can't create a conscious simulation might just be the best evidence that we're in the original base reality.
Okay, so let's just go there for a minute. Let's pretend it's true. Let's say we wake up tomorrow and we know, for a fact, we're living inside a giant computer program. What does that even mean? How would that change anything about our lives, our purpose? The implications are just staggering. Philosopher David Chalmers says, look, our creator might just be some teenager in the next universe up, but that doesn't make our pain or our joy any less real to us. Physicist James Gates points out something incredible. If we're code, then reincarnation is suddenly on the table. They could just run the program again. But then there's a pretty chilling warning from philosopher Preston Green. He argues we should stop looking for proof, because if we find it, our simulators might just see their experiment as contaminated and, hit the delete button.
And that leads to maybe my favorite piece of advice on this whole topic, from physicist Max Tegmark. Whether you believe any of this or not, this is a pretty great way to live. If there's even a tiny chance we're just characters in some cosmic video game, we might as well be the most interesting characters we can be.
In the end, we probably can't prove this one way or the other, at least not right now. But what an incredible question to ask. It forces us to look at the universe, at its mathematical beauty, its weird quantum rules, and our own consciousness, with a totally fresh sense of awe and wonder. If our world is a game, what's the point? What are the rules? And what's our move?